So for this problem, what they want is the x component and y component of this vector. So the information they gave you was the magnitude. Magnitude is just the length of the vector. So this is the vector, this arrow, and this is the length. Magnitude is length. So 22 kilometers. The angle is 135 degrees. They'll specify where they want the angle. For this problem, they said the angle is from the x-axis to this angle, to the vector. So this is 135 degrees. So the first thing you want to do is you want to do trig, because we want to find the x and y component. So once you have this diagram, what we can do so we can do a trig problem is, instead of doing 135 degrees, we can use this triangle right here. Okay, so we can have a triangle right here. So how did I get 45 degrees? Well, this entire angle from one side to another is 180 degrees. Because a circle is 360 from here all the way over, but so 1/2 of a circle is 180. So I did 180 minus 135 to get 45 degrees. Now I make this triangle, and how did I get this side? All I did was I pulled the y component from here and pushed it over here. So all I did was push it over here to get this side. So this side will be y. Now, this is crucial. For these type of problems, if you're finding the x or y component, what you have to do is you have to see where it is on this graph. Meaning, for example, if you have an x component on this side, right? Because usually on a graph, on this side it's positive because it's 1, 2, 3. Here it's positive 1, 2, 3. On this side though, it's negative, right? Because it's negative 1, negative 2, negative 3. And here it's also negative, negative 1, negative 2, negative 3. So what you do is, if you have an x component on this side, it'll be positive. But if you have an x component on this side, it'll be negative. Same thing here. If you have a y component here, it will be negative. If you have a y component here, it will be positive. So pretty much these two sides are positive, these two sides are negative. So for this problem, what we see is this one will be positive, right? Because I took this y side from here. So on this side, the y is positive. But here, though, it's going to be negative. And the only reason we have to specify whether it's negative or positive is we're not saying that it's negative kilometers. We're saying the negative just indicates direction in physics. So negative and positive just indicate direction. Okay, so we continue on. And now we just actually look for the component. So here, I specified that this is the hypotenuse. This is opposite, is the side directly opposite of the angle is the opposite side. And so since we already have opposite and hypotenuse, this is the adjacent. Okay, so this is the common expression, SOHCAHTOA. So here we have, let's find the y component first. So it's the opposite over hypotenuse, right? Because we have one number and the angle, so we can find this side. So we have sine, because since it's opposite over hypotenuse, it goes with this. So it'll be sine. So sine of 45, this angle, is equal to opposite over hypotenuse, right? So we just plug in any information. So hypotenuse is 22, so we plug in 22. Now what we do is solve. So we multiply each side by 22, that cancels, and then we get 15.6 kilometers. So the y component will be 15.6 kilometers. Now we check to make sure if it's positive or negative, and since I got the y component from here, it's going to be positive. So the y component will be positive, and we got that right. And make sure you use the right units. I don't know why, if they would change it, but just to make sure, just check what units they want and make sure you use the right ones. And make sure you're in degree mode, because that will also change your answer. So make sure your calculator is in degree mode. So next, let's find the x component. So the x component here, there's two ways of doing this, and I'll show you the first one. So the x component, so you don't forget, since it's on this side, it's going to be negative, because usually on this side it's negative, negative 1, negative 2, negative 3, so forth. So it's going to be negative x, right? So it's going to be adjacent over hypotenuse. So that's going to be cosine right? Because that's cosine, adjacent over hypotenuse. So that's cosine. And the angle will be 45 degrees. Okay, so let's go down. So it's going to be cosine of 45 degrees, adjacent over hypotenuse. We have the number for the hypotenuse. It's 22 kilometers. So we're going to plug that in. We have 22. Now all you do is multiply each side by 22. That cancels. 22 times this will get you 15.6. And here, notice how I put a negative a. I guess I'll put negative just to make sure I don't confuse you. I put a negative a, so just to make sure I don't forget about that negative. So it's negative a equals 15.6. Get rid of that. We have to make sure a is positive, so it'll become negative 15.6 kilometers. So this is the first way of doing that, negative 15.6. The other way is you can actually do cosine. You can just do it normally, cosine without any negatives, solve everything, and just look. But this way ensures that you don't forget about that negative, because that changes your entire answer, and you'll probably get it wrong if you leave out that negative. So yeah, if use this way is better. But if not, if the negative is confusing you, don't worry about it. And then just at the end, you can just figure out if it's negative or positive. Because for example, let's say, because right now the x component is negative. Why? Because it's on this side. But let's say the x component was on this side, then it would be positive. So at the end of the problem, just check which side it's on, and then from there on you can just put a positive or negative sign to indicate if the x or y component is positive or negative. I hope that helped, and thanks for watching.